So, what do you think this is? A light? An ornament of some kind? Well, it's actually a Bluetooth speaker, and it's what I'm going to be showing you how to build in this video. As you can see, the speaker looks visually charming, resembling an old valve amplifier or an Edison light bulb. The light it gives off is warm and cosy, and it can softly illuminate a room in an evening, which is a great way to chill before bed. Sound quality is excellent too, as the glass functions as the speaker's enclosure, allowing for a full-bodied sound, which I'll be demonstrating later in the video. Now the speaker also fires the sound downwards, which is then reflected in all directions by a cone, so that there's no sweet spot, so that you get optimal audio no matter where you're standing. And the best part is that it's really cheap to build as well. So without further ado, let's get to it. Despite appearances, this project is actually very easy to make. And the first thing to work on is the base, which houses the electronics and supports the glass and speaker. As this is going to be 3D printed, it first needs to be designed on the computer. If you're new to 3D modelling, you can find a link to the one I designed in the description, which includes a short tutorial on modifying it to house different sized speakers or glass tops. As you can see, it's separated into 3 different sections. The top section will house the speaker and also supports the glass, while the middle section is shaped like a cone so that it will reflect the sound outwards in all directions. The bottom one simply houses the electronics. I printed mine at a high resolution, which took around 3 hours for each piece. Don't worry if you don't have a 3D printer, however, as there are many 3D printing services available online, some of which are very reasonably priced. As you can see, due to the nature of 3D printing, they do have tiny little steps visible on close inspection. I want them to be smooth, however, so I sanded them down to take the worst of it off. They're still not perfect, but that can be dealt with in just a moment. It's now time to join them together, and whilst we're at it, we need 4 lengths of enamelled copper wire for later conducting the sound signal and also carrying the power for the LED filaments. These need to be inserted through the holes on the 3D prints, progressively building them up from top to bottom and gluing them in place. Super glue would work well for this, but as I used ABS plastic when printing my pieces, I could just dab a bit of acetone onto each side, which softened the ABS temporarily, allowing them to be strongly bonded together and effectively become a single piece. So it's looking pretty good, but I want to make it even smoother beyond what sanding can do, so I'll be giving it an acetone vapor bath. I have an entire video on this subject, which you can find a link to in the description, but essentially it's just a case of wedging some paper towels inside the bottom of something like a glass vase and drenching them with acetone. The 3D print can then be placed on a flat surface, like a plate or a piece of glass, with a small brushless fan next to it for circulation. The vase can then be placed over the top, trapping the acetone vapours inside. As the 3D print was made with ABS plastic, which as shown earlier dissolves in acetone, it will start to gloss over and become smooth as the vapour gently softens the outer surface. There are a few safety precautions to take when working with this method, as acetone and its vapours are highly flammable, so be sure to watch the previously mentioned video for more details before trying this yourself. As you can see, it's very effective, and has removed all traces of the stepping, instead becoming super smooth, no longer looking like it was 3D printed. It can now be sprayed with plastic primer and then painted any colour you like. I've gone with a thin spattered coat of matte black, which makes it look somewhat metallic. So now it's time to add the speaker, and the one we're going to use is a 2-inch full range driver that's fairly inexpensive yet sounds great, a link to which you can find in the description. As the back of it will later be visible through the glass, we can neaten it up by taking off any labels and then using some fine sandpaper and water, followed up with metal polish, to give it a more shiny appearance. In an effort to improve its appearance even more, we can carefully remove the mounting brackets with a rotary tool, ensuring that no particles bounce into the interior of the speaker, and lastly we can remove the ugly connector rail. With that done, the speaker on the whole looks a lot more presentable from the back and can now be mounted into the base. To help seal it so that there are no air gaps, I added a small amount of silicone sealer all the way around the internal rim, after which the speaker can be pushed into position. Two opposite wires can now be cut down, and so that we can solder to them, we can use a knife to carefully scrape off a chunk of the enamel, after which the speaker cables can be soldered to each of them. With that done, we can now start working on the internal light to give it that old retro feel. For this we'll need 6 low voltage LED filament bulbs. These are tiny little things, but look really cool when lit up and are very inexpensive. Links to them are, as usual, in the description. These need to be soldered up in series, meaning that the positive side of one gets linked up to the negative side of the next, like a chain. When soldering these, it's a good idea to hold them with a piece of wet paper towel, as it's very gentle and will also wick away some of the soldering heat, although it's still a good idea to be as brief as possible with this to prevent any damage. Once they've been soldered together into 2 sticks of 3, we can solder them to a tiny length of copper like so. Now the 2 remaining wires on the base can be bent into shape using some pliers. Care needs to be taken with this to ensure that each side is equal and straight, and once the LEDs are soldered to them, it should look something like this. Looking good. Now it's time to work on the electronics so that we can stream audio wirelessly to the speaker and also have the LEDs illuminate. So the first thing to do is drill a hole for the power socket at the back, as we're going to power this externally rather than with a built-in battery. We can now glue an adjustable voltage step-down board inside and solder it to the now added power socket, being careful of the polarity. This is for powering the LEDs, but before we do that we need to plug a 19-volt power adapter, like one from an old laptop, into the power socket and use a multimeter to monitor the output voltage of the step-down board, adjusting its trimmer until it outputs a stable 16 volts or so, after which it can be soldered to the copper wires that support the LEDs. Make sure that it's disconnected from the power adapter when you do this, however, as it would likely damage the board if you were to solder it at the same time, and also note that I've added a 1 ohm resistor to one side to help limit the current to the LEDs as they warm up. With that done, the LED should now illuminate softly with a warm glow. Each LED is actually rated for 3 volts of power, which, as they're in series, would mean that if given 18 volts they would reach their maximum brightness. This is just too bright for this use case, however, which is why we've gone with 16 volts, as it's the sweet spot as each LED receives 2.7 volts, making them much dimmer and easier on the eyes if looked at directly. Not to mention having a hugely longer lifespan as they don't even become warm to the touch. Now we need to work on the Bluetooth amplifier. We could just use an all-in-one amp and Bluetooth module for this, and while this is probably the best option for beginners, from my experience they've often had comparatively poor performance when it comes to distortion and interference noise, so instead we'll be building one out of several low-cost components, which you can find links to in the description, along with a circuit diagram on how to fit them all together. I recommend that you follow the diagram for this section, but I'll just give you a quick overview of the process here to give you a rough idea. So first up is the Bluetooth receiver, which needs to be popped open and have the connectors removed to make it smaller. Its audio output can now be soldered to the input of the amplifier, going through 2 6.8 kiloohm resistors to first mix it to mono and reduce the overall volume so that it doesn't overload the speaker. Now to power the Bluetooth receiver we need a 5-volt regulator like this one, whose output needs to go through a small isolator before hooking it up. This prevents noisy ground loop interference. Lastly, the power wires and speaker wires can be added, and the whole thing can be glued in place and soldered up. So now the whole thing should work as intended, and you should be able to stream music to it from your phone. But as there's no enclosure, it will sound very thin. So for this, as you've seen already, we're going to use a drinking glass. This one isn't anything special, it's just from my local supermarket in fact, but it does have a nice shape to it, so it's perfect. Mounting it is just a case of clipping it into the base like so, which completes the build. After plugging in the 19-volt power adapter, the LED should light up and the Bluetooth module will pair with your chosen device. Now, you might have thought that the speaker having a glass enclosure would result in unpleasant resonance spikes, but this isn't the case as it's well sealed to the base and actually delivers a remarkably solid sound due to its rigid cylindrical shape. Take a listen. So that's a success, I think. Not only does it look good, but it sounds good too. Don't forget that you can find all the links to everything that you need to make this in the description, and I've also recently set up a Patreon account, so if you do like my projects and want to support what I do, feel free to check it out, and if you want to contribute, it will be greatly appreciated. But other than that, I'm Matt, you've been watching DIY Perks, and I really hope I see you next time. Goodbye for now.